And we were like, but they're installed in the old building. And they said, yeah, but you can't install new ones. So we were like, can we take the old ones out of the old building and put them in this building? And I said, sure. So that's what we're going to do. And then we woke up one morning and the building was knocked down. And we're like, oh, now they're under piles of rubble.
You should make murals on it.
That'd be cool. Okay, so if you got a number larger than 1, raise your hand. Oh, good. Okay. Oh, if you got a number less than 1, raise your hand. Okay. Less than 0.5. Less than 0.8. Interesting. 0.3 is the correct answer. Yeah. 0.3. So in solving for the number of moles, you just multiply your molarity by your volume. So you got a molarity of 1, a volume of 0.3, and you got 0.3 moles. Okay. Are we going too fast? We're good?
Down, Captain.
I'm giving you all she's got, Captain. I cannot do a medical.
I just got dead, Captain.
Not dead. I'm not a medical worker. Okay. So this is typical of the exercises you're going to see, the real kind of life kind of exercise you're going to see. How many grams of hydrogen chloride are found in 100 milliliters of a 2 molar solution? 2 steps. There.
Oh, good. I don't ride horses.
Yo, city always sit there.
Oh, don't say that. I will. Okay, I will.
Do this.
5. You just culture knowledge. Mr. Bugs, can dogs have AIDS?
Because to have AIDS, you have to have HIV, and the H in HIV is human.
Okay. Boom. Dog does not have AIDS. Come on, dude.
Okay,
Basic, bro.
here we go.
It's basic.
If you got a number in grams larger than 1, raise your hand. Okay. Larger than 2? Larger than 5? Larger than 10? All right, yeah, about 7-ish. 7.2. 7.2, 7.3. Okay. Now this next one is going to be the last of this type of exercise, and it's going to be what you're going to be doing on Thursday to prepare for the golden penny lesson.
Ooh, golden penny.
The golden penny lesson. What mass sodium hydroxide is required to be dissolved in 250 milliliters of water to make a 2.8 molar solution? Well, first, yeah, so you're going to need moles first. Then once you have moles here.
You gonna do some tricks, Mr. Butters?
No. I don't do trace. Do not.
Oh, those are kind of cute. I got this.
Hey, respect.
So I'm hearing some chatter, so it sounds like you guys are ready to share your answer with the neighbor?
Yes.
So cool. Share your answer with the neighbor, see what you got. If your number doesn't match your neighbor's number, hopefully you can figure out why. What's the first part? Okay, if your neighbor got a number larger than 1, raise your hand. If your neighbor got a number larger than 1, if your neighbor got a number larger than 2, raise your hand. If your neighbor got a number larger than 3, raise your hand. Larger than 10? Larger than 25? Larger than 30? Good, okay, good. So you didn't have to, you weren't worried about the powers of 10, 28 grams. All right, next. This is where things get a little tricky. Are you ready? Understand, guys, the simulation that we're doing on Monday requires very strange amounts of moles and molarity, so you need to use your exponent key. We're going to turn number of ions into moles, and it's important you realize that 6 times 10 to the 23rd ions equals a mole. Now, if you're like me and you're using the exponent key, this is very easy. It's just 6e23. That's what that is. If you're like a mathematician and you want to like use the times blah blah blah, you have to put it in parentheses. You have to go 6 with an open parentheses, 6 times 10 caret 23 close parentheses. Winner? Sir, what is the concentration in molarity when 3 times 10 to the 23rd ions are dissolved in 1.1 liters of water? Realize that 3 times 10 to the 23rd is half a mole, and 0.5 moles over 1.1 gives you 0.45 moles. Anyone need me to explain where that number came from? Okay, so the first thing we did is we said, all right, if you got 3.0 times 10 to the 23rd ions, and you need to convert that to moles, then 6 times 10 to the 23rd ions is equal to 1 mole. So that gave us a number of moles, 0.5 moles of ions. And we divided that by 1.1 liters to get 0.45 moles. See how the pattern goes? Now, in tomorrow's simulation, the concentrations are going to be normal, and it's going to like zoom into the molecular level so you can see the ions. So we're talking about like tens or hundreds of ions. So consider this. What is the concentration of a solution of 87 ions in 2.4 times 10 to the negative 23rd liters?
Okay, that's fine.
Yeah, warm up that exponent key. What is the concentration when you have 87 ions, just 87, in a concentration of 2.4 times 10 to the negative 23? Cheese? I love cheese. Well, some cheese.
I like cheese and rice.
Cheese and
It's a
rice.
great number.
I prefer cheese and rice.
How'd you get that number? Wrong E. I got a big number. It's just E.
Mother or father.
Oh, he didn't understand what's going on.
Baby,
104 miles between Chicago and DC. Got it right.
Okay. So again, 87 divided by 6 times 10 to the 23rd is a tiny itty bitty number. But you're also dividing that tiny itty bitty number by a tiny itty bitty volume to get a normal concentration.
Yeah, got it.
Okay. Does anyone need more time? Okay. Another minute or two? Or minute? Good. You're dividing 87 ions by 6 times 10 to the 23rd, dividing how many moles you have. That is an itty bitty number. But you are dividing that itty bitty number by an itty bitty volume to get a normal size concentration.
Go get it.
If you got a concentration larger than 2, raise your hand. Larger than 5, raise your hand. Larger than 10, raise your hand. Did you get 6?
Yeah.
All right.
I got 5.92.
Okay.
5.92, close enough.
I got 7.
Okay, last exercise for the day. This leads to it. This exercise has 3 parts. How many ions dissociate for every mercury 2 bromide molecule? Everything is binary. So how many total ions dissociate for every mercury 2 bromide molecule?
Wow, this is confusing. What kind of strength?
Bromine is negative. Chilaxin with the halogens.
Oh,
-1 bromine next to -1 chlorine and -1 iodine.
they're just lamping.
Everybody like, we're looking for another lecture so we can complete our octet. Have to lock up chlorine so you can dissolve the dishes. Okay,
That's what I do about that.
how many, the show of fingers, how many total ions do you got? You got 1? You got 2? You got 3? You got 4? I'm seeing a 3, a 3, a 2, a 3, a 3, a 3. Mostly 3s. Okay, yeah, there's 3. So there's 1 mercury 2 plus and 2 bromines. Using what you've learned so far today, I need you to answer these 2 questions. Actually, it's 1 question, 2 parts. What are the 2 concentrations of a solution of 14 mercury 2 plus ions and 28 bromine ions in 1 times 10 to the -16 liters of water? Question?
For the how many ions one? Is it 3 moles? There's 3.
It's for every molecule. So it's 3 If it was 1 mole of the molecule, then it would be 3 moles. But it's how many ions for every 1 molecule.
Okay.
So do we take the moles and multiply it by 6 times?
No. So this exercise is basically saying, for every 1 mercury molecule, how many ions do you make? So every mercury bromide is going to break into 1 mercury and 2 bromines. And then, using that information, if you had 14 mercuries and 28 bromines, what are the 2 concentrations of their ions in that molecule?
3 molecules, not how many
I think you're reading it wrong. Okay. So it's basically saying, how many ions do you get from a single mercury molecule? The single mercury bromide molecule produces 1 ion of mercury and 2 ions of bromine. Your answer is going to be times 10 to the negative 7. Your answer is going to be times 10 to the negative 7. They're both going to be times 10 to the negative 7. And it should make sense, if you did this properly, that the concentration of the bromine is going to be exactly twice that the concentration of the mercury. Because there's exactly twice as many iodine or bromines than there is mercury. Your answers. So, the concentration of the mercury is 2.3 times 10 to the negative 7. The concentration of the bromine is 4.6 times 10 to the negative 7. Questions? Don't understand. Okay, so, not a question, but I'll still respond to it. So we're basically taking the 14 ions of mercury 2+. And we're realizing that there are 6 times 10 to the 23rd ions in 1 mole of anything. So far so good? So in this case, it's going to be the ion of mercury. So this is going to give you a mole of mercury 2+ ions. Okay. You're going to take that molarity, or sorry, the moles, and you're going to divide that by 1.0 times 10 to the negative 16 liters. And that's going to give you your concentration.